In this video, we're going to discuss UAV image processing using ArcGIS Pro. We will load a group of images in, and then we will do some processing to create a mosaic of these images. And once we create the mosaic of these images, we will do some additional analysis and processing. The first thing we'll need to do is download some UAV images. I've already done that on my computer. We will give you a location where you can get some images from a UAV. They usually come in a zipped file folder. You'll need to decompress this zip folder so that you can actually work with the individual images. We're going to start by opening up ArcGIS Pro and loading those images, and then we'll continue the process to create a mosaic. So we've opened up ArcGIS Pro. I'm going to start a project. We'll just use the default name here. We're going to go over to the Imagery tab and say New Workspace. Notice a new window's opened up here on my right side of my screen. I do need to give it a name, so I'm going to call this UAV 2. I'll skip the description right now, but you should give a description. Notice drone has been loaded in here, and that would be appropriate for a UAV. We could also have satellites or aerial data that we could be loading in here. The background map was chosen to be the topographic map. You can choose whatever background map you would like. We'll click Next, and we'll click on Add, and we need to tell what folder our data is in. So it's on my data drive, it's in downloads, and we need to find the data here. UAS images, open that, and we'll click on the image folder, but we won't go any farther than this because we want to know where all the images are located, not just a single image. We're going to click OK, and you can see the images are being added. It's using something called Exif Data, and we'll look at that in just a moment. So it knows the spatial reference of each image. They're all in the same spatial reference, and it knows what camera even was used. So what is Exif Data? We'll switch back over to my PowerPoint slide here, and we'll go to the next slide. And notice here, all this information is stored with the image. So this is the metadata about the image. Things such as what was the speed of the shutter and what was the f-stop of the camera, how many pixels are in an image. All kinds of information is stored. The important information for what we're doing right now is this information near the bottom of the Exif data for one of the images, and it tells us the latitude and the longitude, and it tells us the height above sea level, 177.39 meters. So we've got this information that's recorded with each image, and that information is read by ArcGIS Pro to do part of the analysis. We'll switch back to ArcGIS Pro. So we've now brought in the images. We're going to click Next, and we're going to leave the defaults there, and we're going to click Finish. Depending on the speed of your computer and the amount of data and the size of the images will also depend on how long it takes to load the images and position them correctly. What you're seeing here is the flight path. What's actually important is the position. That's the center of each image that was taken. Then the flight path is just a straight line, so that's not a true flight path. It's just from point to point, so it's a set of straight lines. So we can see information is coming in. So you can see part of the image is loaded. That's as far as it's going to go on actually showing us pieces of the image because of memory allocations and things like that. So we can look at this and do a little bit of understanding. We can take the images off and just see the flight path. This was the footprint of the images that I turned off. We can turn the image itself off and just look at it. This is where the National Geospatial Technology Center of Excellence is located on the southwest campus of Jefferson Community and Technical College in Kentucky. That's the complete boundary. So we can see some interesting things going on there. I'm going to turn it back on like it was before we did anything. Under the Ortho Mapping tab, I'm going to select the Adjust button. And I'm going to let it use the defaults here. And it's basically going to adjust all our images. So I'm just going to click Run. When I've done this in the past, the runtime might be as much as 20 minutes. So we'll obviously cut out some of that dead air time in what we're doing. Okay, the process has been completed. You can see it took nearly 34 minutes on doing this process. And if we come down here, we can turn on the tie points. These are the points that are common points on the different images. The reason we have common points is that we overlapped our flight path both side to side and front to back. Therefore, each area was imaged multiple times, and so there's more than 10,000 tie points. You can actually go to the properties or look at the attribute table and determine how many tie points there is. But you can see the number of tie points are showing here, as well as some other things that have been calculated along with residuals and so on and so forth. The next thing that we would like to do is we would like to come in and create an orthomosaic of the whole area. So under the map, Ortho Map tab, I'm going to click on Orthomosaic and select Next. And we're going to use all the defaults. You can later come back and experiment with different default values in here, but we're just going to use the defaults at this point. And we're just clicking Next to go through here, and we will say Finished, and it will start computing how the orthomosaic should lay out. So what it's doing is what should be on top of what, and how do you twist or stretch an image to make it all work properly. Again, this process can take several minutes, again depending on your computer speed, and dead air time will be cut out. Alright, you can see the orthomosaic has been drawn. We still have our flight path showing here, so I'm going to turn off our flight path. You can see where the center of each image was that's used to make this mosaic. I can turn those off as well. And if you look at this image carefully, you will see that there are some problems with it, like there appears to be a break here in the building. We can see the different colors between the different photographs, even though I tried to do a color comparison and brightness comparison. We can see here the names on the buildings, the administration building, the auditorium, and so on so forth. There should be a name on this building, which is LRC, but using the wrong pieces of images, it sort of disappeared. You can see there's some breaks in the sidewalk, but those don't actually exist, or not in the sidewalk, but the curb. So you can see some things like there's another little error. So you can see there are some problems, but overall it's made a fairly nice mosaic for us. The next thing I'd like to make is a shaded relief. To get to the shaded relief, we're going to be under the Analysis tab, and we're going to be under Raster Function, which happens to be already open over here on my right hand side. I'm going to scroll down here to Surface, and the surface that we're going to choose is a shaded relief. The raster that we're going to use is the Orthomosaic that we just created. So I'm going to select that. The azimuth angle and the altitude can be changed. Think of this as the angle of the sun. So what time of day was this photographed at? So you can look at shadows, things like that. For the moment, we're going to leave those in the default. We could change the Z factor to stretch the vertical while we leave the XY plane constant. Sometimes this is done to show elevational changes more discreetly. So we're going to say create new layer. And now it has taken basically the hillshade, which we did not directly create, and the Orthomosaic, and put them together. And so it's created a new raster called Shaded Relief Orthomosaic, and you can start to see some elevational changes. Things that are gray are the lowest areas. You can see the ground and the rooftops and so on and so forth. So you can see some of the things that we can do with a shaded relief. The last thing we're going to do is we're going to create a dim. So we're going to go back under the Ortho Mapping tab. We're going to select for our layer the Orthomosaic, and we're going to say create a dim. A dim, remember, is a digital elevation model, and so what we're going to do is look at elevation of the buildings. Since we photograph these buildings from multiple different angles, we can create a digital elevation model without using something like LiDAR. So we're going to say next. Again, I'm going to use the default, and we'll say finished. And so it's going to work on creating for us a digital elevation model. We could then later use this digital elevation model to create things like a 10 from that, or we can drape the Orthomosaic over top of it and things like that. Again, some of these processes take some time, so we may cut out dead air time in the process. As you can see, the dim has been created. I'm going to just turn off a couple layers that we're not using. And so what we have is the white areas are the highest elevation, and this pale green and yellows are some of the lowest elevation. We can go over and look at the table of contents. We vary from about 130 meters to about 149 meters. These buildings are two-story buildings, this reddish color representing 2 stories, but there are some areas that are only 1 story. These areas here are only 1 story. A tree that is 2 stories, another more than 2 stories tall spot on this image, and then we have another tree over here. This is another building that is partially being made, and so forth. And so you can see that we created a digital elevation model. From that we could create a contour or 10 or other data similar to what we have done in other parts of the course.